Go, go to your table of contents, please. Now, I think these pages are one off, right? So you need to put page 63 for synthetic division. Hang on, I'll get there. Okay. This review long division, we did that yesterday when we did the introduction. So let's go on down here. And I think this, you're going to fold this into a booklet, okay? You're going to fold it like so. Now, if you'll notice, what you see here on the front of your pink page is exactly what we did yesterday. You'll see the number that goes right here is what makes this 0. And then you'll see that we took the coefficients of every one of those terms plus the constant, and don't forget the sign that goes in front of them. And remember, the only two operations we used, multiply, add, remember? Now, when we get this answer, we're going to talk about what that means. We had, at the beginning, we had x cubed, that's not where I want to look at it. We had x cubed divided by x. Well, what's x cubed divided by x? So it's x squared. So that answer, this right here is the coefficient of x squared. So it's 1x squared plus 3x plus 7, and the remainder, none. There's no remainder. The reason I gave you a calculator, you can do it for addition if you need it, but I have a bigger purpose in a little bit. So let's open this thing up. Synthetic division only works when you have x minus a number or x plus a number. If you have x squared, if you're dividing by x squared or dividing by x cubed, synthetic division does not work. You have to do long division. All right, let's look at this one. Let's talk about how to set this one up. What's going to go in the box? What are we going to divide by?
X minus 2?
No, a number, a single number. What number makes this equal to 0? So -2 is going to be in your box. Now, let's talk about the numbers that we're going to put across here. You remember when we did long division, we had to put a placeholder of 0 in if we were missing an exponent? You have to do the same thing here, so don't forget that. Do we need any placeholders? No, we don't need any placeholders. So the numbers we're going to write are 2, 7, and 9. Do you remember how it goes? Bring down the 2. Two times -2. Then we think add. Add those, what do you get?
3.
Then you multiply 3 times -2. And then you add. Nothing else to do. That's all there is. Let's talk about what our answer means. We did 2x squared divided by x. What does that give you? 2x. So this is the coefficient of x, because this is 2x. So our answer here is 2x plus 3. What is this? That's the remainder. So we're going to put plus 3 over, wasn't it x plus 2? Circle in or box in your answer so we can find it. think you'll find synthetic division real simple. Okay, let's try this second one. What are we going to divide by synthetically? Say again? 3. What numbers am I going to use for my coefficients and constant? Do I need any placeholders? Yes, I need a placeholder. Where? I have x cubed, I have x squared, and I have a constant. I'm missing x, so I'm going to have to put in, so 2, 4, 0, 5. Bring down the first term. Question. Always bring down the first term. 2 times 3. Then you add 10. Thank you. Just waiting. Yep. If I take x minus 3 and I set it equal to 0, how would I solve that? Add 3 to both sides. So that's why it's going to be 3. 10 times 3. Add. Then 30 times 3. What does that mean? This was 2x cubed divided by x. What's 2x cubed divided by x? 2x squared. So this is the coefficient of x squared. So 2x squared, help me out, plus 10x plus 30. How is the exponent right here going to compare to the exponent right here? One less every time. Question or stretching? Okay. Okay. Let's continue. We'll do these two together, and then I'll have you do the two here at the top by yourselves and see how you do there. What number are we going to divide by? -4. Do we need any placeholders? Where? Yep, I need one here for y to the third, and I need one here for y. All right, so what numbers are we going to put in? 1, 0, 9, 0. Perfect. Where are you going to make the most mistakes? Number 1 is forgetting to put in placeholders if they're necessary. And number 2 is just making silly mistakes in adding and multiplying. Here we go. 1. Okay, did you finish? 1 times -4. Add. -4 times -4. Add. 25 times -4. Add. Bleh. -100 times -4. Add. All right. So let's talk about what this answer is going to look like. What's that 1 going to be? 1y to the what? Do we need to write the 1? Nope. So we can just write y to the third. So y to the third power. Talk me through it. minus 4y squared plus 25y minus 100 over, what was it, y plus 4? Perfect. A lot easier than the long division. Do you have questions so far? Did any of you go on to that next one? What's in the box? 3. Placeholders? No? Numbers? 7. 7 times 3, 21. Add. Negative 2 times 3 is negative 6. Add. 7x minus 2. Now we're going to come back and talk about some of these in a little bit, especially these ones that have a remainder of 0. That's where your calculator is going to come in. All right, you try these two. I'll do them up here for the benefit of the people who are going to watch this video, and you do them yourselves, and we'll see if we get the same answers. Tell me if I mess up my arithmetic. I want us to go back to this problem right here. Okay? Now, I want you to do something on your graphing calculator, so please get your calculator out. You're going to have to remind me what this is because I'm getting ready to lose it because I'm pulling up my calculator. On your calculator, go to y equals and clear out anything you got there. In my pre-cal and AP calculus classes, we call that the walk of shame. Okay. What I want you to put in here is 7x squared minus 23x plus 6. Just go to y equals right here. Now, I don't necessarily care what the graph looks like, except to say this. What's the shape of the graph? Parabola that opens which way? Up, because leading coefficient is positive. So otherwise, I really don't care about the graph at this point. I want you to go to table set, which sits right there. Second window. And I want you to start your table at 0. And we're going to, the delta table, that means how you're going to count. We're going to count by 1. Then go to table. What were we dividing by on that problem? No, I think that's the other one.
Oh, 3.
X minus 3. And so in your box was 3, right? 3. I want you to arrow down to where x equals 3. What's the y value? 0. You look back at your pink sheet. What was the remainder on that problem? 0. Kind of interesting. Go back to y equals. And I want you to go, all right, shush yourself. Shush yourself. That's not what I meant to do. I want you to put this one in your y equals, but just replace y with x. Just make it say x to the 4th plus 9x squared plus 30. No, we're going to go back and we're just going to clear out the first equation. And I can't remember what it said. X to the 4th plus 9x squared plus 30. Everybody have it in like that? Now, go to your table. What's the matter? Did you get lost?
Okay.
What, go ahead. How did I type in what? Oh, how did I type in x to the 4th? Okay, I'll show you. Yeah, x, and then that caret, hat, and then the 4. But what you have to make sure you do, x raised to the 4th. Do you notice that your cursor is still up in the exponent? You have to click the right arrow to get it out of the exponent. Now I forgot what the rest of it was. Plus 9x squared plus 30. And then we're going back to table. What did we divide by? Synthetically, what did we divide by? Huh? What's in the box? What's in the little box? -4. Now, I want you to use your up arrow key until you find x equal -4. What's the y value? 430.
Whoa.
You did. -4 times -100 is positive.
Yeah.
So this is, oh my gosh, that was your remainder. Oh my gosh, that was your remainder. Okay, that's weird.
So we can just leave it.
You're not going to. I'm not going to let you. But so what's Tanner asking? Can we just use our calculator? No. What does that mean on the graph? What does that mean on the graph? So here's what we're going to do. We're going to graph that one. Just go zoom 6. Okay, we can't even see that one. That's maybe not the best. No, that's probably not the best one. Not showing anything, so I need to go to a simpler one. I'm going to borrow yours and look. Those are big. The one upper left corner on the left side, the one that says 2x squared plus 7x plus 9, put that one in. 2x squared plus 7x plus 9. We could have done the other one, but we would have had a lot of window work to do, and I didn't want to take the time to do that. Go to, snap. Go to table. What did we divide by on that one? When x is negative 2, what's your y value? What was your remainder? Oh my gosh. What does that mean on the graph? Huh? What? I didn't hear what you said. Yeah, that's right. Now, I want you to go to Zoom 6 because we'll be able to see this one. Now, I want you to do this. We're going to go to calc, which stands for calculate. So go to second, trace. And I want you to do option 1. Now, you should have your cursor flashing down here where it says x equals. You see that? When your cursor is flashing, it's asking you to give it something. We're going to type in what we divided by, which was negative 2. So you type in negative 2 right there, and then hit enter. What's the y value? Oh, where have we seen 3 before? That was the remainder. The number that we divided by and the remainder, what are they on the graph? Not necessarily, it's not on this, it's close, but it's not. But it's a point on the graph. Not by hand. Well, you don't like graphing on the calculator? When you synthetically divide by negative 2 and your remainder is 3, that's telling you got a point on the curve. Negative 2, 3. Oh my gosh. I think that's pretty cool. Now, there was one specifically that I wanted us to look at, and it was this one right here. This one right here. Graph it. Well, we didn't look at the graph. 7x squared minus 23x. 7x squared minus 20 plus 6. Go to graph. What can we not see? How do we see the vertex? What do we need to change? What do we change on the window? Y minimum, because we need to see lower. So we want to change the Y minimum. What do you want to try to change it to? Well, it got to be negative, right? Negative 15 or 20. Okay, try negative 20. All right. Now, what did we synthetically divide by? Ask Mary to help you.
It's like,
Does she know how to help you there? Because I saw that. What did we divide by? What was in the box when we divided that? You're quit wasting my tape.
caught whacking.
Go to table. Don't even start with me. You're gonna don't. We divided by 3, right? Look down here. Go to x equal 3. What was your remainder?
0.
Remainder was 0. Now, do Zoom 6, not Zoom in, Zoom 6. Yes. Now, I know I can't see the vertex, don't care. Second calc. You don't need to repeat everything I say, okay? I need to keep my sanity here. We're going to option 1, all right? Option 1. 3. What point did we just find on the curve? So oh my God, that's an x-intercept. Oh my gosh. What are the coordinates of the point? Ah, look. My coordinates of that point are, now, here's the deal. This is the big deal. When your remainder is 0, you have an x-intercept. That's a big deal. You remember how we were solving equations, quadratics, by factoring and by quadratic formula and by completing the square? Remember all that? Look right there. You can get the calculator to help you with that support as well. When the y value is 0, you have got an x-intercept or a solution, an answer, okay? All right. Now, we're going to go away from that. We're going to go back here to your pink, and all right, this stuff down here that says synthetic substitution, I don't want you looking there yet. I'm going to show you what that is on a problem we've already done. So let's see, which problem were we just working on? We were just working on this one here, right? I'm just going to show you something. You don't have to write it down because you don't have a place to write it down. What were we dividing by synthetically? 3, with so much gusto, right? 3. What if I substitute a 3 in here everywhere I see an x? Now you're going to use your calculator. 7 times 3 squared minus 23 times 3 plus 6. All right, you're going to help me out with the arithmetic. 3 squared is 9. 9 times 7 minus 69. That's 0. What was the remainder? Look right there. I've never seen that look on your face before. Okay, let's go to this one. What did we divide by? Everywhere you see a y, I want you to substitute in -4. Now listen, when you put that in your calculator, you type it in like this with the parentheses, otherwise it's going to be wrong. What do you get when you do this? 430. What was 430? That was your remainder. Oh my gosh. Now, what else do you know about that? You know that if we graphed, what's one point we know is on that curve? 430 is the y value. What's the x value? -4. Oh my gosh. So we also know that -4, 430 is on that curve. I'm trying to get you to see all the...
Pardon the interruption. If you have not already, please dismiss the volume.
I'm trying to get... Shut up, you're not the manager. I'm trying to get you to see the connections. We're doing the same thing, just in different ways. What you are finding essentially is a point on the curve by synthetic division or by substitution. Do I have to do what? Synthetic substitution. That's what we just did. Substituting that value in is called synthetic substitution. I want you to look at example 1. Now, you've got some room. We're going to do this problem 2 ways, okay? 2 ways, you hear me? We're going to evaluate P of 4. So we're going to figure out when X is 4, what is P of 4? So I want you to put in 4 everywhere you see an X. What's that give you? Good. That's what I got in my head. I was hoping that was right. Yeah. I'm a nerd. I accepted a long time ago. All right. You should get 7. What if we do synthetic division? Well, no, hang on. I would be dividing by 4. It doesn't say X minus 4. It just says X equals 4. So if I did synthetic division, I would be dividing by 4. And what would my numbers be? 1. It hadn't been that long since we did this. -4, 3, -5. Don't ask, I don't know why. Yeah. Ho, look at there. Now, what point are we sure of is on our curve? No, it's not 7 is not a point. A point is X comma Y. 4, 7. I know the point 4, 7 is a point on that curve. That's what I know. And I can find it by doing synthetic division or what we call synthetic substitution. Let's do one more. Do you remember how to put a fraction into your calculator? Well, yeah, kind of. Okay. Second quit. Clear. Alpha y equals is how you put in a fraction. But on that one, it says 6 times x to the 4th. So you're going to do 6. And then you're going to do parentheses. Alpha y equals option 1. My keystrokes are down here if you get lost.
Like the parenthesis number dash. Yeah, like
I think it's easiest if you use the fraction command, alpha y equals. I really do. Put in -1 over 3. Right arrow out of the fraction. Close your parentheses. And then raise to the what power? 4th power. Raise to the 4th power. And then get out of there. And then go ahead and finish it. Go ahead and finish it. Let's see. So we got minus 25. Alpha y equals. Put it in the bin, pumpkin. And this is cubed. And this minus 3 times -1/3 plus 5. This is how we're gonna end. What did you just find? You found a point on the curve. What point did you just find?
Negative
What's
one,
the x value?
negative 1,
Negative 1/3.
7.
You just found a point on that curve.
Oh.
And if you had done synthetic division with negative 1/3, what would your remainder have been? 7. There you go. There you go.